Hello everyone. I hope all of you are doing good. Today I will discuss about an important topic, relation of mathematics subject. Okay. In our daily lives, we come across as many patterns that characterize relation, such as father and mother, brother, sister, daughter, mother, teacher, student, etc. In mathematics, also we come across some relation such as a line L is parallel to line M. A number M is less than a number N. X greater than or equal to Y, etc. In all this, we notice that a relation involves pair of objects. Okay. In this chapter, we learn how to live in this pair of these objects. Okay. So let's start now. What is relation? To know about relation, you need to learn about Cartesian product. Now we will discuss about Cartesian product. Let A is equal to 1, 2, 3 and B is equal to A, B, C, B to non-empty set. The Cartesian product of A and B is denoted by A cross B and is defined by set of all x comma y such that set of all x comma y such that x belongs to A and y belongs to A. For example, the set is 3 elements, contains 3 elements 1, 2, 3 and B set is contains 3 element A, B, C. So, A cross B is equal to, we define 1 to A, 1 to A, 1 to B, 1 to C, 2 to A, 2 B, 2 C, 3 A, 3 B and 3 C. Okay. And B cross A is equal to B cross A. B cross A is equal to A2 1, A2 2, A3, B1, B2, B3, C1, C2, C3. Okay. A question may come out our mind. If again A cross B and B cross A are equal. Okay. A cross B and B cross A may not be equal. Okay. So now I will discuss relation. So suppose that A and B be two non-empty state. Okay. A relation R from set A to B is a subset of A cross B. Okay. For example, A is equal to AB and B is equal to contains 1 and 2. Then A cross B is equal to A2, A1, A2, B1, B2. We know that the total number of subset of A cross B is 2 to the power these elements. Cardinal number of A is equal to 2 and cardinal number B is equal to 2. So 2 to the power 2 cross 2. Okay. The subset of A cross B is a relation such as r is equal to a1 a2. This is an relation. This is an relation. Okay. Now let us discuss types of relation using mind. Okay. First of all, what is anti-relation? A relation R in set A is said to be empty relation if no element of A is related to any element of B. Okay. Phi is an empty relation of any set. Okay. Phi is an empty relation of any set. Next, universal relation. A relation R in set A is said to be universal relation if each element of A is related to another element of B. Okay. So, universal relation R is A cross A subset of A cross A. Okay. Now we will discuss main three topics, types of relation, namely reflexive, symmetric and transitive. Okay. First of all, reflexive relation is very important for you. Let A is a non-empty set and A element, it belongs to A. Then it implies that A belongs to R. For all A belongs to A, it implies that A belongs to R is called reflexive relation. A question may come out of our mind, what is the total number of reflexive relation? The total number of reflexive relation in a set is 2 to the power n square minus n, where n is the cardinal number of any set. Okay. Next, symmetric relation. Let A and B be two non-empty set. If A comma B belongs to R, then it must implies that B A belongs to. Then this type of relation is said to be symmetric relation. The total number of symmetric relation is said is 2 to the power n into n minus n plus 1 by 2. Okay. The total number of reflexive and symmetric both is 2 to the power n into n minus 1 by 2. Okay. Transitive relation. Transitive relation is a type of relation where A comma B belongs to R and B comma C belongs to R, implies that A C belongs to R. Okay. This relation is said to be transitive relation. What is equivalence relation? A relation R is said to be equivalence if it is reflexive, symmetric and transitive. Then this type of relation is said to be equivalence relation. For example, let Z is the set of all integers. A relation defined on Z such that R is set of A comma B such that 2 divided A minus B is an example of equivalence relation. Okay. Now let us discuss about this with an example. Okay. Now we will discuss types of relation with an example. Let A is a set contains 3 elements 1, 2, 3 and Cartesian product of A cross A is this. Okay. We defined a relation R this. Then we notice that up wall A belongs to A implies that A belongs to R. This and this and this. Okay. So R is reflex. Do you understand? Next, for wall AB belongs to R implies BA belongs to R. 1 2 belongs to R, imply 2 1 belongs to R. So R is symmetric. So R is symmetric. We also notice that 1 2 and 2 1, that is AB and BC belongs to R, implies AC belongs to, okay, 1 2 and 2 1. So 1 1 1 M belongs to R. So R is a transitive relation. Since R is reflexive, symmetric, transitive, so R is an equivalence relation. Okay, thank you everybody. That's all for today. We will meet again in next class. Thank you.